It's the only way to keep people together over long interstellar distances, Brandon.
Very difficult. All right, so
go
ahead and jump in. All right, so this is Science Storytime again with Jim and Brandon. I'm Brandon, and I'm here with my friend Jim. You may have heard Jim on the last interview that we did, which was about the battery, where we learned a couple of exciting things about the history of electricity. Is that still banging around in your head, Jim?
It rings a bell.
Cool. Well, so just a reminder, my background is in analytical chemistry, and Jim's background is in rocket science. Aeronautical engineer, doing a bunch of cool things. So I thought this time we would have a discussion about something that maybe Jim and I know a little bit more about than we do electricity. So we're going to start off on September 6th, 1895. An exciting time to be alive. And we're going to start with Walter Robert Dornberger. He's born in Gießen, Germany. As a child, he wanted to become an architect, but his father insisted that he join the army, which at the time was the path to high society in Germany, where you get to... I don't know if this is still the time where you get to wear the helmet that had that big spike coming up off of it. Maybe. Yeah,
it definitely was.
Maybe that's what made people feel very impressed with you. You had a fancy helmet. So, at the start of World War I, 1914, at age 19, he enlisted in the German army and became a lieutenant in the artillery corps serving on the Western Front, which was not the happiest place on Earth. It's a lot of trench warfare. People are, getting mustard gassed. It's a kind of a downer place to be hanging out in war. But during this time, there were a lot of advances in the army going on, and especially in artillery, as generals, really wanted to find ways to break the stalemate that was developed by trench warfare. So he was on one of these gun crews. I'm sure you have an idea in your head about what these things look like.
It's like just one step above the one from the cartoon with the big fuse sticking out the end of it.
It pretty much is. I was looking at some photos of these things, and they look almost exactly like that. But they took crews of up to 6 people to work, and to actually be able to use them functionally, you had to have a knowledge of mechanics and mathematics, and they were used to fire these 18-pound shells over a mile distant, and they would do it at a rate of 4 per minute, which that's pretty impressive.
Yeah,
that's
pretty impressive.
Every 15 seconds launching one of those off. So Dornberger, this guy, his job was to do all of the mathematics to calculate where the shell was going to go and where they're actually going to launch it. So you had to do this rapid mental math in the middle of a war zone, and you had a little book that had a bunch of tables in it that would help you, but that's about all you got.
Science's foremost minds at the Western Front shelling each other.
Yeah, definitely. So if you were a really accomplished engineer mathematician, you were sent off to get exploded. That's what you were doing. So I actually have an example problem from the Field Artillery Central Officers Training course that the U.S. was giving people in World War I.
Okay.
There's a series of lectures on this from a guy that was at University of Texas that he published as one of the courses he was doing. So, all right, Jim, pretend that you're in the middle of the Western Front. Okay. People are shooting each other, and you've sent out your observer from your artillery battery. And you've sent out your observer. He's 2,000 yards from your battery.
Should I get a piece of paper?
Yeah, you might want to do that.
Oh, God. All right, hold on.
Okay.
Okay, I'm back with paper and pencil for this impromptu physics quiz.
Okay. In World War I, having a pencil and paper was known as cheating because your pencil and paper was probably either eaten by rats or used to stuff up a bullet hole of one of your friends.
Oh, God.
So we'll start again.
Okay, 300 yards away.
Okay, so you're at your artillery battery.
Yeah.
Your observer is 2,000 yards away from your battery on his little lookout post.
Okay.
And he sees that the target that he wants to shoot is 3,540 yards away from him.
Those are both away from you?
Those are both away from the observer.
Is the observer in front or behind the line?
In front of the line.
Okay.
And he sees that the angle between the battery and the target is 114 degrees. So what's the range that you need to shoot in order to hit his target? You have 30 seconds before you and your entire team are dead.
No! All right, so...
And 2 more soldiers on your side are just shot by this target.
They're dead now. Oh, man. Yeah, I'm failing, Brandon.
The cries of men in no man's land are wafting up to your ears as they call for their mothers and children and wives. The horror of war, Jim. It's unfolding before you, and you're sitting here trying to do math.
I know. This is hard. I could figure it out, but on the spot, I'm panicking right now.
All right, good. So this is, so it's just a simple, you're just figuring out the length of another angle on or another leg of a triangle, right?
Yeah, there's so many triangle legs here.
3 of them, in fact, I think.
Yeah. All right.
Okay. So all right. So Jim is showing me a picture here real quick.
Okay. Is that right? Is this here the 3,500 yards?
Okay, so meant? I have bad news for the listener. Jim has made this so much more complicated than it needs to be.
I did exactly what Brandon explained.
Jim has put together 3 different triangles, and this explains... All right, so you definitely overthought you and your team into death here.
Okay. Well, you didn't.
Right.
I didn't get to take the course at University of Texas on this. They weren't offering it when I was there for some reason.
That's true. It was 85 years at the ground by the time that we went there. So the answer for those of you doing it at home is 4,721 yards. You also had to do corrections for the amount that the gun jumped off the ground when it was firing, because it would buck up as it was being shot. You had to correct for wind temperature, wind direction. So there's a whole bunch of stuff. Long story short, you couldn't be a dipshit and do this job, or else you.
Not like me.
Second Lieutenant Jim would have shot off one round, would have landed on the inside of his own team's trenches, and would have been summarily demoted. And your job would then be to ride the donkey as it dragged it along.
They'd send me to the lookout post 2,000 yards on the other side of the line.
Yeah,
there's going to be a lot of rifle fire whizzing past you. Don't worry about that. Just keep...
Yeah, don't stress about it. All right, so Dornberger did this job for 4 years. So he got in at 1914, and in October of 1918, so he's gone through almost the entire war, less than a month before the war ended, he was captured and taken as a POW. So, real bummer. Almost got to the end, but he was captured by the U.S. Marines, and he spent the next 2 years in a French POW camp. Most of this time that he was in this POW camp was spent in solitary confinement, probably because he kept trying to escape, but I can't figure out why he was kept in a POW camp for 2 years. The war ended in 1918. He was captured in 1918, a month before it ended, and they just held on to him for 2 years. They didn't let him go.
Yeah, that's kind of strange. Was that was normal, or is this guy kind of an exception?
I have no idea. I have no clue if that's just how they rolled back in the day, but I wouldn't imagine you'd want to keep holding on to just thousands and thousands of enemy soldiers for years after it's done.
Maybe the idea is you trickle them out, If you there's a standing experienced army, they're demoralized, but you don't send a group of 10,000 of them out all the same day. Yeah, just march that way. Germany's back over there. See you guys in 5 years when you regroup.
That's probably a really, really good idea. That probably explains a lot of it.
Yeah, I think given that World War II occurred, maybe 2 years wasn't long enough.
Wasn't long, yeah.
Should have trickled them out for 15 years. That would have...
Maybe kept holding on to a couple of them who caused a lot of trouble in beer halls in the next decade. So he managed to get out in 1920, and he returned to Germany, and he moved to Berlin. And at this point, since he had already had some experience with mechanics and engineering, being an artillery engineer, he enrolled in engineering classes, and by 1930, he had finished a master's degree in mechanical engineering. the pieces that we have put together so far right now are engineering, Germany, the 1930s, and the military. So it's a pretty good mix so far, right? Like, no trouble's going to come out of this.
Seems fine.
So he finishes his degree in 1930, and Dornberger is tapped by the government to work on something that had been mainly the field of academics and amateurs up until this point. Do you have any ideas?
I have a guess what it might be.
All right, Jim, what's the guess?
Is it the V2 rocket?
We are closing in on that.
Yeah, it's like the V1 rocket. I assume that came first.
Yeah. Yeah, so he's put to work on rockets. He's told to begin developing a secret project to make a liquid fuel rocket for the German military as a long-range alternative to artillery. So, artillery is kind of a pain in the ass. It takes soldiers and horses and has to be near the fighting front. There's logistical problems.
Not like launching a rocket.
Yeah.
Nothing as complicated as... Okay. That's an interesting way to try and simplify your problem.
Well, I think they wanted something that was both long-range and also had flexibility about where you could launch it, because their method of long-range ordnance up until this point was something called the Paris gun, which I don't know if you've ever heard about this, but it's a gun that has a barrel that's 117 feet long, and it can shoot a shell that's 25 pounds up to 80 miles. So they would just build one of these and then only have it aimed at one place. So the Paris gun, because it only shot at Paris. Like, you couldn't move this thing after you built it.
Okay, yeah, that's pretty wild. I didn't know they were fixed.
Yeah, you couldn't do anything else with it. You're like, well, all right, that's done. I guess we can either build another one each time we have to change where we want to shoot, or just do something else. So their something else was trying to develop rockets, and a bunch of these guys were in communication with Goddard in the U.S., writing him things. I think they were talking to him right up until like 1939, asking questions about, so, help us make our rocket better. And he's like, of course, all in the name of scientific inquiry.
Oops.
Oops.
Now he has like a NASA lab named after him.
Accidentally helped the Nazis.
Oh well.
Now you're an American hero. Dornberger's given this job, but does not appear to have been given a ton of money to really make this all work. So he starts renting some test site space outside of Berlin from an amateur rocket society in Germany called the Verein für Raumschifffahrt.
That's exactly how it's pronounced, actually.
I believe so. My German is impeccable. It's the VFR for short. It translates to the Society for Space Travel.
Awesome.
But so there's a couple weird things about this, and I want to get your opinion on it, being, that you've built rockets and all.
Okay.
So this test range was built on top of an abandoned ammunition dump.
Yeah, that seems bad. No, actually, I think that SpaceX's facility in Texas is on like a ex-Navy like weapons range. So there might be like some shells somewhere out there. I don't know.
A couple unexploded shells.
Is definitely poison already, So.
So you don't have to worry about messing it up too much.
Yeah, I'm not sure.
Well, yeah, so they were launching their rockets up on top of a whole bunch of unexploded bullets, that kind of stuff that the German army had to dump after World War I. The second bit was, I'm not really sure why, for his secret rocket tests, he did it at a public field and was letting the amateur society both watch and help him. Information
traveled slowly back then. So it's like hard to conceive, but like there was like 100 people who knew about that, and that was it. Even though it was like right in town.
I guess that's true, that each one of those people could have written a letter to everyone they ever knew, and it would still reach fewer people than one person tweeting about it today.
Yeah, it's pretty crazy.
Okay, so he let all these people help him out, and whether that was good or bad, we don't know. But it might have been kind of lucky for him that he did, because it was there that he met a young engineering student named Werner Magnus Maximilian von Braun.
Okay. Well, he was pretty good at rocket stuff.
He was pretty good at rocket stuff. he was pretty good at a lot of rocket stuff, and that ended up being a little bit of a problem during something called World War II. So, in 1933, the Nazi Party came to power and immediately moved rocket research onto the national agenda, which means that they were restricting its development by civilians. So if you were working on it, you had to be affiliated in some way with the government. You couldn't just go off and do it on your own. So Dornberger, who had started working with von Braun and liked him a lot, arranged for a grant so that von Braun could continue his work in 1934, so they could do it together. Von Braun finished his dissertation in 1934, which was called Construction, Theoretical, and Experimental Solution to the Problem of the Liquid Propellant Rocket, and that was classified by Germany until 1960. No one was allowed to look at his dissertation.
That makes a lot of sense. Like, even today, you have all sorts of restrictions. Like, I can't talk to someone from a foreign country about how to build a rocket, or I go to jail. And you'd find
really, I didn't know that. Like, it's super locked down. It's something called ITAR.
So basically, even though these days, like all the dangerous rockets, like the international missiles and stuff like that, they're mostly solids or some hypergolic fuels. But like, and what SpaceX worked on, what I've always worked on is like a liquid rocket, like these rockets that von Braun was working on. But they're not actually that good at being weapons once they get above a certain size. Because you have to the good ones have cryogenic propellants, and it's just a pain in the ass to maintain all the systems. You'd rather just stick a solid, basically like a glorified firework that can steer itself into the ground and launch those guys off. Because I take that back. It's not a glorified firework. I'm sure it's still very complicated, but it's very inert. You can just sit there and you can launch it on a minute's notice, and that's the Minuteman. That's the class. That's a class.
Oh,
example.
I didn't know that's why they called it the Minuteman. Those are like the old ICBMs that the U.S.
Exactly,
had.
And they have 5 stages or something crazy because the efficiency of the solid rockets is less, but they can launch on demand and last 30 years in a bunker with basically relatively low maintenance. And
yeah, because the liquid ones, the liquid that's being used in there is often liquid oxygen, right?
Yes.
So that's very, very leaky. It wants to get out, and it'll start boiling off. So it's like Jim's talking about. It's very difficult to keep that in one place for a long period of time because it wants to turn just into gas and disappear.
Exactly.
Isn't one of the benefits of the liquid ones that you can turn them off and on, whereas the solid ones, you light it and then that's it. You just have to run.
Yeah, solid ones basically just run continuously. They do some clever tricks of the geometry of the fuel rod, the shape, the internal shape of where it's actually physically burning, so that it can change its profile over time. So more thrust at the beginning and then less later. So there's some clever tricks there you build into it. For the most part, you definitely can't turn it off. You might be able to do some crude throttling though. But
all right, so is that a portion I need to cut out since you're telling me a little about rockets? Is that too much for the layman to know?
No, that's readily available in a publicly available textbook. So I'm at liberty to say it's something of that nature, I guess.
Okay, all right. Just want to make sure I'm not getting you in any trouble here.
Yeah, I wouldn't want that kind of trouble.
Okay, so we're jumping back to von Braun for a moment. All right, so he's given a grant in 1934 to keep working with Dornberger. A quick aside, von Braun finished his undergrad degree in 1932 and had his doctorate by 1934, which is some real bullshit, in my opinion.
Yeah.
Did his doctorate in 2 years? Come on.
That's not fair. That's not fair to you, Brandon.
That's completely unfair. I really wonder if he got bumped up due to the fact that his work was so sensitive and so high on the national agenda. They're just like, yeah, give him the degree. He's done now. All right, you come work for us.
Yeah, I mean, I think maybe, too, back then, to do something really novel in a field of research like rocketry, you could write, some F equals MA shit down, and, you take that, I don't know, a few months down the path, and they're like, wow, you've really honed this in from a bunch of dudes just, building a cylinder in their backyard to, we actually know why it works and how big it needs to be to, push a certain size bomb to a certain location or whatever else. Yeah, I mean, isn't that, I guess, is that the metric for like most PhDs, is to have published something novel, basically, to push your field further, right? And maybe that's a little bit easier the earlier on you are.
It's definitely a lot easier the earlier on in the field. There's a lot of low-hanging fruit, or fruit that's already fallen onto the ground that you can just pick up. Yeah, so anyway, I'm horribly jealous of the fact that it only took him 2 years, but I guess that's why he's super famous, and I'm not. All right, so we're going to skip over a whole bunch of World War II, but like you were mentioning, during this time, Dornberger and von Braun helped to develop the A and V series rockets that were rained down across Europe during 1944 and 1945. So I knew about the V2 bombings in London, but what I really didn't know before I was looking this up is that more V2 rockets were launched at Antwerp in Belgium than anywhere else. It was like 1,600 of them fell on Antwerp. I have no idea why. Do you have any idea why the Nazis were so angry at Belgium?
No, I don't know. I think it was just like nearby, so
yeah.
Why not? I have no clue.
I guess maybe the math of it was a little easier. Just be like, it's the easy target. Just launch another couple ones at Antwerp today, and the brass will get off of our asses. We can go knock off early and drink today. All right, so by 1944, both Dornberger and von Braun were thoroughly disheartened by the way the war was going. Both guys could kind of see the writing on the wall that this was going to be a mess. Von Braun mentioned at a colleague's house that he'd rather be working on a spaceship than working on ballistic missiles.
So you just get off the hook. You're like, I really wanted to build a spaceship the whole time.
Yeah. Well, this is something that the Nazi Party did not like at all, because a dentist who was a spy for the SS overheard him talk about the fact that he wanted to build a spaceship, and he was imprisoned by the Gestapo for a few weeks.
Oopsie. Before
being released by the Fuhrer to continue his work on the V2 rocket.
Wow. Yeah, I can just imagine that. Like, the Gestapo is like, oh yeah, this guy's bad news. He just gets plucked out. They don't really know how, and then all of his like colleagues are like, no, that was like the one guy that actually knew what was going on. Like, we need him back. They're like, fine, send him back.
Oh. So I think the hilarious part, and the part that I'm fascinated by in this story, is the idea of a dentist spy.
Yeah,
I think that makes the least sense of any potential spying profession, because their entire job is circling around, preventing you from speaking by having something in your mouth.
Yeah,
I don't know how many secrets they're hearing in the course of their day.
That's why the waiting rooms, they put you over there for so long.
That probably explains it.
They're just waiting for you to slip up. They've got listening devices all over.
Because all I could imagine was them standing over you with, like, the things in your mouth and the little thing, like, you are having a traitorous thought, yes? I got you now! Just a couple of grunts that sound insufficiently supporting of the party. All right, so we get to the end of World War II, and it's a pretty crazy story, but a lot of the leaders from all the rocket research ended up being brought to the U.S. through something called Operation Paperclip. Mm-hmm. You ever heard of Operation Paperclip?
Yeah, they sent everyone to Huntsville, Alabama, basically. And they were like, yeah, we forgive you. Now build our space rockets and military rockets, basically.
Yeah, that's pretty much exactly what happened. They grabbed all these Nazi scientists. They gave them false records where they were like, Nazis? What Nazis? You guys have never heard of Nazism, right? Wink. And let them all come over to the U.S., make a whole bunch of different things. We just pumped them all for information on rocketry and how this thing all worked. Which is pretty insane, because they had killed a bunch of people and built terror weapons and used slave labor to make them, and we just kind of swept it all under the rug.
Yeah, pretty crazy.
It is pretty crazy. It's an astounding story to read up on. So Dornberger went on to become actually the vice president of Bell Aircraft.
Oh, okay.
And he developed the X-15, which was the first manned hypersonic aircraft capable of suborbital flight.
Pretty
which was
rad.
Yeah, it was pretty cool. So it would be dropped from the wings of a B-52 bomber, which was named Balls 8. And it would take off like a missile, and it would reach speeds of 6.7 or Mach 6.7.
Yeah, that's how they like tested out some of the first in-space thrusters, I think. Or if it wasn't specifically for that, they actually needed, that vehicle had thrusters on it, so that once it got so high in the atmosphere, going so fast that you couldn't use the wings or flaps on the wings to like steer the thing anymore because the air was so thin it would do nothing. So in order to like change your angle and re-enter the atmosphere after you like went up on your parabolic shot, you'd have to fire thrusters, gas thrusters. So pretty amazing machine, like this hybrid between two environments. But,
it's pretty cool. So he also helped develop the concept for the space shuttle, which was based on his X-20 Dyna-Soar design. Mm-hmm. Dinosaur being spelled D-Y-N-A-S-O-A-R, Dyna-Soar. He also developed the Rascal, the world's first guided nuclear air-to-surface missile.
Huh.
So
solid product line, I guess. Like space shuttle, nuclear missile. He liked to call them the little rascals. He thought it was fun.
Yeah, so he's a super interesting guy with absolutely no talent for coming up for good names of his projects. The Dinosaur, the Rascal, and the Balls 8. Just...
Yeah, I always thought Dinosaur was kind of a bizarre choice.
So, yeah, he led a pretty interesting life. He pretty much stayed firmly in the military end of things. But von Braun, as you may know, on the other hand, went full-on rocket. And he was sent to Fort Bliss near El Paso in Texas. And when he wasn't being pumped for information about rocket development, von Braun was working on his one true love, which was spaceflight. And von Braun, in 1952, I think, wrote a 90-page book called Das Mars Project, or The Mars Project. Have you ever heard of this, Jim? I'd never really run across it before.
I certainly haven't read it. I might have heard of something like that before, but yeah, I've never read it. So tell me more.
It's his plan for taking human beings to Mars, and he actually did a very detailed treatment of what he thought it would take to send up people to the Red Planet. And I want to run a few concepts and numbers by you, and I want to hear initially how you would plan a project to Mars. Just like
with
a
no
very rough sketch
whatsoever. Okay, yeah.
But like, what would that generally look like? And I want to see if it matches up with sort of how he planned things.
Okay, so you're letting me go first. That's good, because he's going to make me look bad. But, yeah, I mean, so you want to set up a Mars project. Using the technology, should I use the technology we have now, or should I use the technology they had at the time?
Let's just say right now you've got 10 years to plan a project, unlimited funds, so you can use whatever you'd like to right now. What would it look like? Just very broad outline.
It's a pretty good strategy to build just the biggest rocket you absolutely can. So you probably want to co-locate your rocket factory with your launch site. And the reason for that is so that you don't have to like ship it around and go under bridges and stuff like that, or move it around on a barge. You can just build it and then launch it from there. And then the other important thing about that is that you would want it to be reusable, I would think. So that you can do as many trips as possible for the lowest amount of money. And the reason I go big is, for people that are listening, that of the total takeoff mass of any given rocket, only a small fraction of that will actually make it into space, a few percent. And so the bigger you get, the more bang for your buck you get, in that like things like the computers might not get heavier for like a bigger rocket. They're just as complex for any size rocket. So the fraction of mass you're putting towards these things that you can't avoid but to have, gyroscope and a computer and all this other stuff, that all stays fixed.
Okay, so your propellant and payload scale up, but your essentials list stays the same,
exactly.
so that you don't have to keep
basically everything gets easy. Most things get easier up to a point. Going bigger with a rocket gets rid of some of those problems. Although the engines tend to get harder once they get up a certain size, it seems like. But you just can cluster the engines. So you've got a rocket.
Okay, so
and you'd want to.
So you're building a really big rocket.
I would think you'd want to like send many people per trip. More likely than not, a lot of people talk about assembling something in space. If you could make a big enough rocket, and you can have a decent number of people go, maybe you would do like 2 flights, one to send up a habitat, and that goes back down to Earth. Another one, maybe it sends up a habitat and like like some additional fuel, and then the first rocket goes up full of people, gets the habitat, the extra fuel, and then like launches itself the rest of the way to Mars. That's like a typical way. And then once you get there, in advance of that, you would probably send many similar missions using the same machines and land a bunch of habitats and stuff there, like a bunch of cargo, basically, that could get there early.
All right, so I'm hearing you send up some supplies early on, then you put people up to go use the supplies in the habitat that you've already sent there.
Well, I think
how many people would you imagine?
Realistically, to have... If you're really trying to... It depends on what your goal is. But if your goal is to actually put a society on Mars and like have it be self-sufficient, I think you want actually quite a lot of people so that like...
We're just talking for an initial trip. You're going there and you return.
Send like... If you're just visiting, send like 4 people. But if you're going to like set up to stay, you should send like eventually like 1 million people, I think. So that's another reason the rocket needs to be quite large, like even bigger than Saturn V was, I would think, which was the moon rocket. So that you could literally just like put up a lot of people. And that's, again, the key thing being reusability there, because that machine is going to cost a couple $1 billion probably to build or something like that. So yeah, you want to get good bang for your buck on that and use it many, many times. And one other aspect of that is you probably want to figure out a way to do refueling on Mars, and you actually land the ship. You don't like land in a capsule. You like land with the rocket. Yeah. And,
okay. All right, that's ballsy.
Yeah, that's kind of like similar approach to technology like that SpaceX is doing, the like return to launch site. I mean, you just run it in reverse, right? You can land on any body if you have the right algorithm, and you're...
Which is like watching cartoons from like the 1950s where Daffy Duck will land his rocket like straight up and
exactly. So yeah, that's what you want, so that you can not just do multiple trips, like get cargo up into Earth orbit. You want to actually shoot the thing the whole way to Mars, use it to land, refuel it, and then send it back, ideally, for another trip. And that's how you get like the critical mass to actually have a sustainable civilization up there.
All right, I'm kind of liking this. So, reusable rocket that you send to drop people off, and that acts just as a ferry service back and forth. So, you're talking like a real deal interplanetary reusable.
And that's again why it has to be huge. And you might be able to like, there might be ways to break this down and make it a little more efficient or better. Like maybe you put like a super high ISP, which is like a kind of a measure of the miles per gallon of a rocket engine, like tug up in space, something that doesn't have a lot of thrust but can thrust for a very long time, and so get you up to very high speed. So maybe you have a couple like tug shuttles ferrying people from low Earth orbit back and forth to Mars, and that might have some economy involved with it. But the fewer like complicated machines you make total, probably the better. So there might be something to say for like just making like 20 of these like reusable crazy rocket ships, just assembly line. They're not super elegant, they're not efficient. They only, 1% of their total weight is people, but it's so huge that you can actually send 200 people at a time or something to Mars. And then, you can get some efficiency from building the same thing many times. And you can gain greater confidence that it's designed properly as it's more and more successful.
All right, so that's a very interesting approach. We'll come back a little bit later to sort of the tug idea about how you actually move from Earth to Mars. But let's look for a moment what von Braun was planning in 1952, and I want you to tell me how solid of an idea this is for technology at that time. So he proposed that 10 ships be constructed in low Earth orbit using materials that were going to be provided by 950 flights by 46 reusable space shuttles taking off every 10 days to ferry a total of 5.3 million metric tons of supplies into low Earth orbit.
Was it 45 space shuttles?
Good so far, no problems. 46 space shuttles launching every 10 days to make 950 flights.
I mean, that would work. That's kind of, along the same lines. You You just need to get a lot of stuff there, right? Because you're starting out at like technology 0, right? So not only do you have to bring all the things that you need to like eat and survive, it's not just a visit mission, right? Like you need to set up like, you basically need to start from scratch and build industry. So you need like a facility to make steel. You need like a facility to like build like lunar rovers. You need like a car factory out there. So you need to ship a car factory through space in addition to like a ton of other stuff. Like a farm, a greenhouse, all this other stuff. Like, and you just think of how many different jobs and how many different things there are in a normal society here. Hospitals and police station, just like every single subtask, it's like you would still need that, because for it to be anything more than just a visit, you would actually need some structure to keep things going along, like
what percentage of the car factory shipping do you think you can get subsidized by having it sponsored by Toyota, Lexus, and GM? 0.5%?
It would be tough to get enough advertising revenue, I think, to make any of this worthwhile financially. Because right now, what is it? It costs like...
It's like $10,000 a pound or something to get something into space.
The cheapest, most
I think you'd know better than I would, but he's
around 2,000 or maybe like 2,500 now, and like people would really like to get that to 1,000, and I think they can do that with like current technology. That would be like kind of a, but if you got reusability, then you could make that maybe like down by a factor of 10 or something like that, or maybe even 100.
And that's still 5.3 million metric tons.
Even if you got it to $100, $100 a pound, it's still a lot of money.
$1 trillion.
That's not that bad.
Yeah, I mean, what? That's like 6%, 7% of the U.S. GDP.
That's not messing around. That's like
every year.
That's a lot of cost, and I think you could easily, by the time you factor in all the development costs and everything else, I'm sure that you could be well above that $1,000 a pound, right? It wouldn't be surprising at all, especially with what he probably thought it would cost at his time.
Yeah, I'm trying to remember what his projected cost for was. I don't have it, but okay, so he wants to have 950 flights, he's going to have 10 spaceships, and it's going to be a crew of 70 people. They would spend 260 days traveling to Mars. The plan was to descend to the surface on giant hang gliders. Oops. I think they thought the atmosphere was a lot denser than they know now. But the hang glider is awesome. They'd spend 449 days on the surface, and then they would return to their orbiting ships. They didn't say how they're going to return to the orbiters for the 260-day return trip. And the predicted launch date was 1965.
Yeah, 13 years out.
So that's... Do you remember this happening? Well, I remember reading about this, right?
When did we finally get our first space shuttle? It would have been like 80, something like that?
1981 was the first official launch of it. I think there were some test flights in like 78. All right, so here's a few numbers for comparison. Yeah, the U.S. Space Shuttle program flew a grand total of 135 missions between 1981 and 2011. That's 4.5 launches per year. Even though the original plan for the Space Shuttle was to have 50 launches a year, that never happened, so they had 4.5 launches per year. And even the 50 per year falls well short of the launches every 10 days that he was originally
pretty optimistic. Yeah, if you're trying to do 20 flights a year with a single shuttle or whatever, you're going to want all the parts of it to be completely reusable, right? And that's one place where I think the Space Shuttle was at a disadvantage because, 3 of the major components of the system got consumed. And that's the 2 SRBs or solid rocket boosters on the side and then the main tank. Building something as large as that it's a lot of aluminum. If you just weigh it and multiply that by the street price of aluminum, you're going to be, for a normal sums of money that people are used to seeing, they're going to be like, oh my God, that's crazy. You just incinerated $20 million. That's nuts,
Oh, but kind of awesome. So another comparison number is that the Saturn V rocket had a launch capacity of 120 metric tons, and that was for low Earth orbit. And if you wanted to go to the moon, it could carry 48 metric tons into translunar orbit. It takes quite a number of flights to bring up the amount of material that you're talking about doing. Okay, so it seems like von Braun also thought that this whole plan might have been a little ambitious since it never happened. And in 1965, the year that he thought his original plan was going to get put together and go, he proposed another plan. And this one he wrote and published in Popular Science, the magazine. This plan had 6 to 10 astronauts heading to Mars, riding a nuclear thermal rocket using liquid hydrogen as the propellant, which
that's like
is kind of awesome.
Pretty awesome way of doing a rocket, because I talked about that ISP number before. I think it's something like, maybe 4 times more efficient for the amount of thrust you get for a single pound of fuel or something like that. And
yeah, so just the way that this works is you have basically like a nuclear reactor that's getting very, very warm, and you have your reserve tank of liquid hydrogen, and the hydrogen passes along the sides of where the reactor is getting very, very warm. It heats up the hydrogen, pushes out the bottom as thrust. So you just have like a nice, awesome nuclear reactor getting you all your warm stuff going.
It's a pretty simple design, too, except for
generating some propellant.
If it blows up, I guess people will be pretty unhappy about the scattered nuclear debris.
Troubleshooting in space seems a little bit harder on this design, maybe. I don't know. But this would only require 725 metric tons, which is 7,000 times smaller than his original plan.
Wait, how many thousand times?
But still 7,000 times smaller. Going from 5.3 million metric tons to 725 metric tons.
He realized that people didn't have a taste for spending 50% of GDP on his crazy idea.
Yeah, unfortunately it didn't go over. Yeah, so it's 7,000 times smaller than the original plan, but still 15 times larger than the Apollo missions that'll be flying to the moon 2 years after his article came out. So this was also scheduled to go in 1986, which also didn't happen, sending an awesome nuclear rocket to the moon. So another quick aside, in this exact same issue of Popular Science, there's an article about different weather control techniques that scientists are trying to develop at the time. And these include dumping oil on the polar ice cap so that they absorb more sunlight and melt. Or they're also talking about straight up just dropping nuclear bombs on the ice caps to vaporize them and provide more clouds. And then you just kind of push the clouds around and make rain where you want them to go.
We're so lazy now, Brandon.
It's true. People had big ideas back then. Just enormous, insane ideas. Yeah, and they also said that the use of the modern, in quotation, supercomputers of the 1960s would allow them to completely model any and all results of the climate, and so they can totally predict what happens, which is the most amazing hubris I've ever seen in the entire world, because I work with climate modelers now, and all of them are just like, we make it up as we go along, the computer models mean nothing. It's not quite that bad, but it's certainly, no one's claiming to have all of the answers, and we have supercomputers that do, I don't know, a trillion times
it's
more.
It's still hard to crunch the numbers.
The ones they had back then.
I mean, even like something as innocuous as like air flowing around, like some little winglet, some small little simulation, can take quite a long time to process. I mean, I guess, I'm not using a supercomputer on a daily basis, but it's like, okay, if we can't simulate fluids in like a 2-dimensional space that is, a few inches by a few inches wide, like very quickly, how do you model the fluid dynamics of the entire planet? It's pretty amazing.
They thought they had it nailed down, and they wanted to add some nuclear bombs to melt the ice caps and just get shit done. They didn't have time for any of this. So we've talked a little bit about the plans that they had for getting to Mars, but what do you do once you get there? So you mentioned a little bit earlier, but that people don't want to live inside of domes for the rest of their lives. They want to be able to have another world that humans can live on and occupy, with houses and picket fence, and they wanted to get away from the Red Menace, since this was still during the Cold War times. The problem is that Mars doesn't really have an atmosphere in the same sense that the Earth does. It's only about 1% the pressure of the Earth's, and 95% of that is carbon dioxide. You can't breathe that. So you need both higher pressure, and you need more oxygen, and you need a higher temperature and some liquid water. How do you solve this problem?
I heard about one idea that sounded pretty wild, but I think it's it's so crazy it just might work kind of an idea. So you like make like an array of either like mirrors or like some sort of space-based solar power in Mars orbit, and you like construct a giant like either super reflector or and sun solar concentrator, or like a big laser beam. You basically just like put that in orbit around, like, let's say just put it around the equator or something like that, and you just have it like ablate the rock that is like, it just blasts the surface of Mars and like turns all that, I guess rock has a bunch of like carbons and hydrogens and stuff in it, and you just blast it and set it on fire or turn it into plasma or whatever, and it just vaporizes, and you like cut a trench that's as deep as the Grand Canyon all the way around the equator, and you've got enough volume of gas now to like support life.
Yes, this is exactly what I wanted to talk about. I first read about this in high school. I was at NASA for like a competition thing, and they had a whole bunch of books on terraforming out for us to read, and the books were like manuals from the 1970s. And it was this plan that NASA had where they wanted to construct a giant orbiting lens around the equator. And like you're saying, you burn something a mile wide and a mile deep around the equator. All the rock there is made of silicates, iron oxides, carbonates, things that have oxygen in them. So if you just vaporize it, that volume of rock has enough to increase the pressure and increase the oxygen content of the Martian atmosphere, enough to breathe. And it is one of my favorite batshit insane science ideas in the entire world. Just, no one has time for somebody to go around and dick around for a few centuries to change this planet. We are going to melt the center of it until we can inhabit it. Fight this problem with fire.
For ambition at all. It's not really a measured approach either. Like some of the other ideas out there are like, you like send space algae there and like allow that to gain a toehold and spread over the planet, and like then 300 years later you can move in. It's like humanity is not that long. Like, we don't have that long of a time horizon. They're like, if this doesn't help my kids out, then screw it. That's like that's the best among us. Like,
we are completely incapable of handling long-term problems, and terraforming is definitely a long-term problem. So there's a couple of other proposals that are out there. One of them, it calls for initiating a runaway greenhouse effect on Mars. The polar caps on Mars are made out of CO2, not water like they are on Earth. So another idea is that you can send orbital mirrors around the poles to direct sunlight and just heat those up. So instead of just burning a hole in the center of the planet, you can just heat the poles up and create a CO2 atmosphere. You still can't breathe it, but that'll get you like most of the way towards somewhere between 10% to 50% of the Earth's atmospheric pressure. Yeah, so that's one method where you heat the poles up using the mirrors until you get all the CO2 in there. Surprisingly, some of our methods have not changed from the way we talked about melting the poles previously. They still have plans out there to drop some nukes on the surface of the poles and make CO2 that way, or cover them in like boot black so they lower the albedo.
Boot black? Like shoe polish?
Yeah, boot just like
black.
shoe polish. Yeah, you never heard that when you used to work as a tiny little Dickensian orphan having to go around in 1800s London and shine shoes for a living? You'd take a little bit of the coal from the chimney sweep and use that for the boot black.
Yeah, I didn't know. That didn't happen.
All right, fine. I guess you were always a fancy engineer, never had to scrape some money together by doing some other jobs. China has suggested that they just take all of the CO2 that they produce from all their coal power plants and ship those to crash into the surface of Mars using cheap rockets. I don't think that has a real chance of really fixing anything. I think that's just them trying to get rid of shit.
Sounds like they're trolling. Like, that is like the most ridiculous thing. Like, I mean, can you really afford to just like start demassing the Earth? Like, I don't know. Like, that seems bizarre, but okay. I do think that's a valid way of like getting rid of like really
not a great plan.
Nasty radioactive garbage. Like, you shoot it into the moon, or not into the moon. That would be bad. Shoot it into the sun, but that would be really expensive. You need.
Yeah, I've always wondered why they don't shoot it into the sun. We can't put it on other planets. I was actually at a planetary protection conference, and that kind of thing
People
is
aren't into
really
just shipping
explicitly a
nuclear material
no-no.
to the moon.
People are very much against shipping nuclear material to the moon, even though
Here's a cheaper
there's no
way
life there.
Instead of sending them to the sun, which is far and it would take a really big rocket, why don't we just make a silo, make it a second moon number 2, and it's just all the nuclear trash, and you put it in a clump, so it doesn't bother anybody, and just floats around up there.
I think you're suggesting an actual Death Star, Jim.
Went there. Yeah.
10,000 years from now, young lovers will go out and look up at the sky and be like, "Oh, the moon is beautiful, and second radioactive moon is glowing nicely tonight too."
Wow! And then when it went over, I wonder if it would make an extra aurora borealis. When it flew over, it'd just light the whole sky up magically.
Oh, it's not magic. That's called radiation, Jim. Oh God.
That's my best idea all month.
Okay. Well. All right, well, jot that one down, and we'll get to work on radioactive space moon 2.
What is that nuclear site that they can never get built called? I'm having trouble remembering it right now.
Oh, goodness. Yeah, the one that's out in, New Mexico.
Anyways, burying it seems to be a political non-starter, so I'm just saying, shoot it into space, Brandon.
Yeah, there's no representative for space. They can't say no. Yeah. All right, so some of the longer-term plans that people have, like you were saying, seed the surface of Mars with a bunch of cyanobacteria or lichen, and that'll start slowly converting all the CO2 into oxygen, so you can hope to breathe it sometime around the year 3,500.
Boring.
Yeah, that one would take forever. Definitely boring. Even if you took all the oxygen out of the Earth's atmosphere right now, if you changed nothing else, just took the oxygen out, and then let the amount of biomass that the Earth has in terms of plants and the algae in the ocean, it would still take about 2,000 years to bring all that oxygen content back up
Lazy
to current
plants.
levels. But so if you wanted to start from nothing, only one cyanobacteria in the surface, you're talking millennia before you have oxygen in the surface.
How would that work with no natural predators? How long before the cyanobacteria is just literally on everything? And then, what do we do when we get there? We're there's bacteria everywhere.
I have bad news. There's already bacteria and plants everywhere on Earth. We just like to not think about it too much. By cell count, there's something 8 times more bacterial cells in your body than human cells.
Are my cells bigger or something?
You're more bacteria than you are human.
I'm mostly human.
Your cells are bigger.
Bacteria. Okay.
By mass, you're
Cell
mostly
count.
human.
Stop using these
By
false metrics.
genome, you're mainly bacteria.
Let's use biomass going forward.
Fine.
Yeah, that's quite a long time. So one other thought. What could you do to modify bacteria or something to be more aggressive at making oxygen than what we have now? Or is that just not possible? Is it a function of photosynthesis, and that's a function of energy flux or light flux?
It's dictated by light for the most part, yeah. So I think that's also where some of those big mirrors come in. You'd want to reflect it and have sections of the planet that are just getting a lot more sun, so you can heat it up and make it a little more amenable. You can melt the ice or the ice caps, get all that CO2 in there, and then have a bunch of plants that have a lot of CO2 pressure, so they're not running out of CO2. They have enough light. You can warm it up so there's some water there. Then you only have to wait a couple centuries or a couple millennia. Still way too long. Alternative number 2 to the orbital mirrors that people talk about is just capturing a shit ton of asteroids that have water and oxygen in them, crashing them into the surface of Mars.
I think. Right? Are you using the kinetic energy of these asteroids to because wouldn't an asteroid hitting the surface be a lot as far as the energy is concerned, it would be a lot like a very large nuclear weapon going off?
I think it's a whole bunch of nuclear weapons going off.
That's not what you're going for. You're just getting the raw material out of it, right?
You're trying to get the water and the raw materials out of it, rather than trying to heat everything up. I mean, I guess you could crash them into the polar caps and get a 2-for-1. But I don't know if that's difficult to do in terms of orbital mechanics. Taking something out of the asteroid belt that's already in orbit.
You'd want an asteroid which was not in the the plane of like the rest of the solar system, which is probably harder to find.
So I kind of like that idea as well. So I'm down with crashing the asteroids into the surface of Mars and also burning the center of it out using giant orbital
Yeah, I'm
mirrors.
also a fan of the mile long trench or whatever mile.
All right, good.
I was thinking though, like maybe instead of doing it that way, like what if you just change the angle of the mirrors every day a little bit, right? So you could just have like a nice, smooth, glassy, like, you know, if you did it right, you could probably give it some cool shapes. There'd be like a giant glassy half pipe all the way around the whole planet. You could also put like a high-speed transit system on it because you have like this perfectly smooth, glassy dish all the way around.
See, that's what I was thinking about. If you burned like the mile-wide, mile-deep thing around the entire equator, you could put the ocean in there, and then you could use that for like shipping goods around the equator. So you just build all your cities on the equator. Everything would be a port city,
And with the
you just move all
ocean-
your goods around that way.
Be freshwater? Because that would be awesome.
It
It
would
be
get salty
important
over
to figure
time.
out if you could surf on Mars or not. There's 2 moons, so who knows what that does.
Deimos and Phobos. People want to use those as like way stations to bring a lot of stuff over. A whole bunch of people with lesser imaginations are like, let's just settle for visiting those. No. Boo. All the boos in the world. All right, so I'm glad to see that we're on the same page for Terraforming Mars. I'm all for it. All the people at the planetary protection thing that I went to would be horrified, but I say go for it. Let's poke around a little bit longer, see if we can find if life's already there. If we don't see it, then let's just get going.
That seems fair. We gave life on Mars a chance.
Yeah, like a lot of people, I'm terribly disappointed that we haven't found anything there yet. I think about the fact that back in the day, like astronomers and everybody just assumed that there was life on Mars. They saw all the canals on Mars and they thought that they were riverways that the Martians were using to transport goods around. Humanity already thought that there was life on Mars for a long time. It could be us.
What's
Might as
bizarre
well be
about
us.
that? Yeah, so I remember hearing these stories, kind of that they're like, yeah, these early astronomers are like, oh, the canals of Martian civilization, but like that was that belief widespread, or was it just like 10 scientists who wrote each other letters were like, well, of course, so we all saw it with our own eyes, and then like all the rest of society was like, I have never left my town yet. Like, I don't even know if there's other towns, you know, like in the 1800s or whatever.
I don't know how widespread it was, but there were still some people that panicked from the War of the Worlds radio program, right? They had to at least be willing to accept the fact that Martians might exist. I know it's not quite as widespread as, you know, the stories would have you believe, but I feel like people were willing to accept it without it being too crazy.
I wonder what the average person thinks now about whether or not there's alien life out there somewhere in general. And then, like, you know, some of the, like, people, obviously you have, like, a lot of conspiracy theorist types who, like, think that, like, aliens visit here on a regular basis and do experiments.
Which is terribly inefficient. Listen, nobody's coming down to Earth just to, like, steal our cattle. That you might as well set up a base.
But yeah, I'm interested to see how that belief has changed over time, even from like the 50s, with like everyone back then have been like, there's probably aliens, they're probably coming soon, like, and now are people more cynical and they're like, nah, there's nothing out there.
I don't know. It's something that's a little bit confusing because you see all these polls that people do where they don't believe a lot of very basic scientific principles, but then also something like 1/3 of people in the U.S. believe in ghosts too. So I don't know.
Interesting. I wonder if like the ghost alien overlap, like if it's exactly the same people, then is that like a ballot? Like, does that count?
Or are you having to do some like data parsing and throw a few things away?
I don't know. No offense to anyone out there that's listening that believes in ghosts. Yeah.
All 33% of you statistically. All right, man. Well, thanks for chatting with me about terraforming and getting to Mars and World War II and Werner von Braun and Walter
Fascinating
Dornberger.
stories. Thanks, Brandon.
Fascinating stories.
Later,
all right, Jim. Have a good one.
Ladies and gentlemen, I have a grave announcement to make. Incredible as it may seem, both the observations of science and the evidence of our eyes lead to the inescapable assumption that those strange beings who landed in the Jersey farmlands tonight are the vanguard of an invading army from the planet Mars. The battle which took place tonight at Grover Mills has ended in one of the most startling defeats ever suffered by an army in modern times. 7,000 men armed with rifles and machine guns pitted against a single fighting machine of the invaders from Mars. 120 known survivors. The rest strewn over the battle area from Grover's Mill to Plainsboro, crushed and trampled to death under the metal feet of the monster, or burned to cinders by its heat ray. The monster is now in control of the middle section of New Jersey and has effectively cut the state through its center. Communication lines are down from Pennsylvania to the Atlantic Ocean.
They're like, you should publish 2 versions of it. One is the, like, if one of us were on Mars version, and the other one could be the OG version.
How long is that delay?
It depends
like
on
a minute?
Where they are in their orbits, right? Because they could be, like, as far as...
yeah.
Like 2 AU, I guess, plus away, right? Or as
That's
close
like
as,
16 minutes then.
Yeah, and then, yeah, probably like 16 minutes, and then as little as almost nothing, right? Like, well, I don't know, and probably not almost nothing, but...
Because it's about a second to the moon.
Yeah, instead of 16 minutes, it could probably be like 4. Instead of like 20 minutes at its worst, it could probably be like 4 minutes at its best or something. But,
all right.
I don't know.
Yeah. Just long enough to make video, like phone sex, awkward. And I'm done.
You just like pre-send each other a bunch of time milestones.
Yeah.
Like 3 minutes and 40 seconds in, I'm gonna start doing some weird stuff to you. All right, you just react accordingly.
Yeah, give me some oohs and ahs about 4 minutes before we hit that mark. That way I get it right on cue.
People can get good at this.
Yeah, time shot. All right, that would be a weirdly choreographed